Sec 1, Chapter 10, Part 1, Sequences. Now, in this part of the chapter, we're going to look at 10.1. Our learning goals is to be able to recognize and then represent these number patterns that you observe into something called a sequence. And in this part chapter, we will introduce you to what is the meaning of a sequence and how to find the different terms in the part of a sequence. Now, what is a sequence? A sequence is actually an ordered list of numbers, meaning order. There's a particular order, there's a particular pattern, there's a particular rule that you need to follow, okay, generated from some patterns or particular shapes and how you observe for a rule to be formed. Okay, this ordered list that's generated from these shapes, these patterns, these rules will be called a sequence. Now, each number in this sequence has a particular name. It is called a term. Okay, and they are usually denoted by, for example, if I want the 100th term, it will be T100. I want the first term, then it will be T1. And T2, so on and so forth. And if I want a nth term, means I do not know which the number is, so it will be Tn, for example. Okay, now it's very natural for us to deduce subsequent terms using the patterns or whichever that we have observed. For example, if I'll give you an ordered list of numbers 3, 5, 7, what do you think is the next number? Well, I think you must have guessed it. The number will be 9, right? So you already deduced and form a pattern in your own that, oh, this is a pattern of all the odd numbers. So I'll list down the next odd number. So it's very natural for you to do that. Now, if that's the case, then we'll know that, oh, T3 is actually the first term that started the sequence. This is called term 1. So like that, what would 9 be? 9 will be actually the 1, 2, 3, the fourth term. So this will be term 4, T4. Okay, so now let's complete the following table of the number of sequences. I'll pick a little few and go through it with you. For example, let's say I have in part E. Okay, what is my third term? So I have first, second, third, fourth, fifth. So my third term will be the term in this pattern, written in this manner, is 3 times 4. And sometimes you can simplify them to the number 12. Okay, but in this case, I don't need you to do so. Just list down the different terms. So for example, if I will have sequence B, what's the first term? The first term will be 0. And what's the fourth term? 1, 2, 3, 4, 6. Now take a little bit of time and fill up the whole table on your own. Have you gotten the answer? Up next, let's take a look at some of the different sequences and then we learn to write down the next few terms of the sequence. Now, there can be a couple of different types of sequence. Now, the one that we are observing here in this case, for example, 2A, we have this sequence 3, 7, 11, 15, and 19. How do we get from 3 to 7? We add 4. 7 to 11, 11 to 15, 15 to 19. We all add a 4 to get to the next term. So if you want to write down the next two terms, that means from 19, I'm going to add 4 it gives me the number 23. And then from 23, I add 4. My next term will be 27. So now let's try. Question B. From 2, how do I get to 9? And then 16. And then 23. And then 30. So what is the pattern that you observe? Well, we added a 7 to get to the next term throughout. So the pattern observed is to add a 7. And then what will be the next term? The next term will be T. 1, 2, 3, 4, 5. So term 6 will be taking 30 plus 7 to give you 37. And what will be term 7? Term 7 will be using 37. We add a 7 to it and you'll get the number 44. Have you gotten the answer? What about part C? Let us observe. How do I get from 1 to the number? I get 2 from the number 1. And 2 to 4. Okay, this is a plus 1. This is a plus 2. What do you think will be the next term? From 4 to 7, I do a plus 3. Okay, so I observe I have a plus 1, plus 2, plus 3. What do you think will be the next one? I'll need to do a plus 4. Let's check whether is this true. From 7 to 11, yes, I have a plus 4. So I have the 1, 2, 3, 4, 5. Term number 6. How am I going to get the sixth term? Taking 11, what do you think will be the pattern? I'm going to add 5. That gives me 60. And what is term 7? I'll take 16. Now I'm going to plus 6 to give me 22. Have you gotten the answer? Question D. 1 to 2 plus 1. 2 to 5. Oh, this is a plus 3. What do you think is the pattern observed? Let's make a guess. This is 1, this is 3. They are both odd numbers. So the next one will probably be a plus 5. Let's check. Is it true? Yes, it's a plus 5. And then we'll have a plus 7. So we are adding odd numbers. So like that, term 6 will be taking 17. I'm going to add the next odd number, 9. And that gives me 26. So term 7, from the number 26, I'm going to add 11. And that will give me the number 37. Have you gotten the answers? Now, this is only a series where we do addition. So there can be a couple of different types of series. So for example, we can do addition. We can add a different patterns of terms to the different terms. Or we can do multiplication. For example, multiply each of the numbers by 2, a series. Or we can do a division, where we divide a certain numbers or write them as fractions. We can also do subtraction, where the number goes from the big numbers to the small numbers. Or we can even have power. For example, like 1 square, 2 square, 3 square, 4 square, so on and so forth. So we can have different power series as well. So now let's try next few sequences to see what are the different types of sequences that we can try to get. Alright, next example. Example number 3. Write down the next two terms in the number of sequence. So let's take a look at the number here. This is 45.5 and it changed to 39. So I can try to do a subtraction probably because the number dropped. So let's say I'm going to subtract this by, oh, there's a difference of 6.5. Let's try, okay? So from 39 to 32.5, if I were to subtract 6.5, I'll get 32.5. So this seems quite constant. We'll do a few more to check our pattern. So 32.5 minus 6.5 will give you 26. So indeed, this pattern is true. So from 26 minus 6.5, I'll get 19.5. So in order to get my next term, this will be 1, 2, 3, 4, 5. The sixth term will be from 19.5, I'm going to subtract 6.5 to give me 13. And then term 7 will be from 13, subtract 6.5 to give me the number 6.5. So you notice in this sequence, the numbers become smaller, hence we try to do a subtraction. So can you try the rest on your own before we go through the answer? Have you gotten the answers? Example number 4. Now let's try the next few series. We have the numbers 4a, 5, 10. So how do we get 10 from 5? We can either do a plus 5 or a times 2. Then how do we get 20 from 10? And then 40 from 20, 80 from 40. It looks more like the sequence is to multiply by 2 times 2 throughout to every single term. If that's the case, how do we get term 6? We'll take 80 times 2 to give you 160. And how do you get term 7? You take 160 times 2 to give you 320. Example 4a. How do we get 6 from the number 2? 6 to 18. 18 to 54. So from 2 to 6 is times 3. 6 to 18 times 3. Now we notice that the numbers get bigger and bigger, so probably these terms will be either a multiplication or we add a larger and a larger number every time. So let's try the next series. 18 times 3, does it give you 84? Yes. And then 54 times 3, we get 162. So that means term 6 will be taking 162 times 3, give you 486. And term 7 will be taking 486 times 3 to give you 1458. Now, part C. What do you observe? Some of them are positive numbers, negative numbers. Some of them are positive numbers. That means a sign changes. And in this case, the numbers decreases from bigger to smaller. But then, so in this case, we'll probably do a multiplication. So how do I get from 256 to 128? So if I'll divide, I will actually notice that this is a division, divide by -2 units. So for this, we will try to do divide by -2 so that it become positive. And 128 to divide by -2 again to give you 64, so on and so forth. So term 6 will be taking -16 divide by 2 to give you divide by -2, sorry, to give you the number positive 8. And then term 7 will be from positive 8 to divide by -2 to give you the term -4. Now the next one over here, 1 to 3, either we have it multiplied by 3 or plus 2. And from here, 3 to 23, the number keeps getting bigger, so we are adding a different number all the time. So this will be plus 20 plus 200. Oh, it looks like this is plus 2000. So if that's the case, to find the term 6, I'll take 2, 2, 2, 3. I add 20,000. That means I'll get 2, 2, 2, 2, 3. Therefore, term 7 will naturally be 2, 2, 2, 2, 5, 2, 1, 2, 3. This one 1, 2, 3, 4, 5. It's about 3. $200,000. Have you gotten the answer? Let's observe the next few patterns. They all look quite peculiar. So from 7 to 6, I have a -1. 6 to 9, that's a +3. The number pattern doesn't look the same throughout. Let's see whether does it repeat. 9 to 8 is -1 again. Oh, 8 to 11 is +3 again. 11 to 10 is plus -1 again. So to get the next term, term 6, I'll take 10 plus 3 to give me 13. And term 7 will be 13 minus 1 to give me the number 12. Have you gotten the answer? Next one. This is 1 over. So all the terms here are all 1 over something. So it looks like the next term will also be 1 over something. Now what do we notice about the number 1, 4, 9, 16, 25? This is actually 1 over 1 square, 1 over 2 square, 1 over 3 square, 1 over 4 square, and 1 over 25 is 5 square. So the next number, term 6, will be 1 over 6 square, which is 1 over 36. And term 7 will be 1 over 7 square, which is 1 over 49. Let's look at G. I have 1. Okay, so it looks like it's 1. Then I have 9. 9, 25, 49, 81. All these are perfect squares. So let me see if we can find a relationship for perfect square. 9 is actually 3 square. 1 can be considered 1 square. 25 is 5 square. 7 square. 9 square. Oh, what do you notice about the numbers? 1, 3, 5, 7, 9. They're all odd numbers. So what will be the next odd number? Term 6 will be, next odd number is 11. So we have 11 square. 11 square to be 121. And term 7 will now be the next odd number. 11 plus another 2 to give me 13 square. So 169. Part H. H has 0, 1, 1, 2, 3. 2 to 3 is plus 1. 3 to 5 is plus 2. 5 to 8 is, okay, this is plus 1, plus 2. This is plus 3. Now 8 to 13 is a plus 5. This looks a little peculiar. It doesn't look like it's following this pattern. So let's start to guess another pattern again. Are the numbers related to each other? Let's check. 0 plus 1 will give you the number 1. And then 1 plus 1 gives you the number 2. 1 plus 2 gives you a number 3. 2 plus 3 gives you a number 5. 3 plus 5 is 8. 5 plus 8 is 13. So it looks like term 1, 2, 3, 4, 5, 6, 7, 8. Term 9 will be taking 8 plus 13. And that will give me 21. So that means term 10 will be 13 plus 21 to give me the number 34. Oh, have you gotten the answer? Let's look at the last few sequences that we have. I have 3 to 4. It looks like it's plus 1. 4 to 7 looks like it's a plus 3. 7 to 11 is a plus 4. 11 to 18 is a plus 7. 29 minus 18 will give me plus 11. What is this pattern? Oh, do you notice something? I have a plus 3, a 4, a 7, 11. Then the next one will be plus 18. So 29 plus 18, that gives me, now this is which term? 1, 2, 3, 4, 5, 6, 7. So term 7, that means it will be from 29, I plus 18 to give me 47. And then after 18 will be 29. So I'm going to take 47, term 8 to be 47, plus 29 to be equals to the number 76. Have you gotten the answer? Next one, we have 2, 3, 5, 7, 11, 13. All these numbers are all prime numbers. So this is the list of all the ordered list of all the prime numbers. So we will have 2, 3, 5, 7, 11, 13. What's the next prime number after 13? That will be 17. So 1, 2, 3, 4, 5, 6, 7. So term 7 is the prime number 17. After 17, term 8 will be the next prime number, which is 19. Okay, now let's take a look at K. 1 to 3, it looks like it's a plus 2. 3 to 7 is a plus 4. But 15 minus 7 is a plus 8. There's no 6. Okay. 15 plus and 31. 31 minus 15 gives me plus 16. 2, 4, 8. 8 times 2, 16. It looks like this is a double sequence. Okay, let's try. If we were to have 2 times 2 to give you 4, 4 times 2 to give you 8, 8 times 2 to give you 16, and then that means the next one over here will be 16 times 2. So 16 times 2 to be 32. So is it a plus 32? 31 plus 32 gives you 63. Oh, that's true. That means I need to add the next number. To get the next number will be 32 times 2 to give you the number 64. So there will be a plus 64 down here. So 1, 2, 3, 4, 5, 6, 7. Term 7 will be, taking 63, I add 64 to it. 1, 2, 7. Then term 8 will now be 64 times 2 to give you 1 to 8. And therefore, from 1 to 7, we are going to add a 1 to 8. And that gives me 255. Do you think that there can be another pattern to this sequence? If let's say I were to take from the number 1, if I'm going to take 1 times 2, and then I add 1 more to it. So 1 times 2 will be 2. 2 plus 1 will give me 3. Now I take the number 3 times 2 to it, that will be 6. I plus another number 1, that will give me 7. So if I were to follow this method, let's test whether is it true. Is this rule true? So from here, if I'm going to take 7, this next number will be 7 times 2, 14, plus 1, that gives me 15. And then the next number here will be 15 times 2, which is 30. 30 plus 1 is 31. Then I'll take this to be 31 times 2. So it will be 62 plus 1, that gives me 63. So for the next number, T7 can also be from 63, I multiply by 2, and then I add a 1 to it. So 63 times 2 plus 1 will give me 127 as well. Then term 8 will now be taking the number 127 times 2, and I add another 1 to it. So 127 times 2 plus 1. That will give me 255 as well. So we have different rules and formulas, but it can give us the same answer. So there could be more than 1 or 2 answers in this case. Have you gotten your answer? Now, if you have a different type of formula or sequence or pattern, please do share it with us. Let's take a look at the sequence L. This is quite peculiar. The numbers keeps getting bigger and bigger. So I'm not sure whether are we adding any powers, any multiplication involved or not. Let me start with pure addition. So if 2 to 3, I'll add a 1. 3 to 6 is a plus 3. It looks like it's adding odd numbers, but if I have 6 plus the next odd number 5, that will be 11, so it's not correct. Okay, not sure, continue to observe. 15 minus 6, that is a plus 9. And I have a 15 to 42. 42 minus 15 gives me a plus 27. Oh, these are all looks like multiples of 3. Let's check again. 1, 2, 3 minus 42 is 81. So I'm adding 81. What are all these numbers? 3, 9, 7. 3 is 3 to the power 1. 9 is 3 square. 27 is 3 cube. This is 3 to the power 4. So our next number should be adding 3 to the power of 5. And that will be 3 to the power of 5 is adding a 2, 4, 3. So the term, next term, 1, 2, 3, 4, 5, 6, 7, term 7 will be taking 1, 2, 3 plus 3 to the power of 5, which gives me the number 366. That means term 8 we will have 366 plus 3 to the power of 6. And that gives me the number 1095. If I to deduce, continue deduction, this is 3 to the power 0, 3 to the power 2, 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4, 3 to the power 5. So this one will be 3 to the power 0. Let's check. Using a calculator, 3 to the power 0 gives you 1. So it's correct. So we can use this method over here. Now, is there any other pattern that we can observe? If you do have such patterns, please share with us and then we can improve on our answers. Now we've come to the end of this part of the topic. We'll move on later to find out the general terms, and that will be under 10.2. Now as of today, this will be your homework. Please take some time to try the questions. Now let us summarize what we have learned for the day. For this part of the chapter, we have number 1, understand what is the idea of a sequence. So a sequence is an ordered list of number, okay, that comes from a particular rule or pattern, and this is called a sequence. Then term point 1b, given the number sequence, are you able to find out the first 3 terms or write down the next 3 terms? So this is a number sequence, for example. Please take a little bit of time to complete these questions on the cover page. We'll see you for the next lesson.